First of all, if you are watching this video on time, you are off to a great start for the final unit of this semester. We're going to go through this unit, we will study for finals, and then we will take the finals, and that'll be it. So this is your last couple quizzes and tests to do well and to get that grade up as high as you can. We're moving away from triangles a little bit. You'll still see them pop up in different cases, but we're going to be looking at some different shapes, or what we would call polygons. Basically what a polygon is, poly comes from many. So we would say a polygon is a many-sided figure made up of segments. Okay. So our objective today is going to be able to recognize the different types of polygons and then find their different angles. We're going to have four formulas that we're going to look at, and basically we're going to make sure you guys know how to use them. So first of all, I want to make sure we know what a polygon is versus not a polygon, and then a couple of specific kinds. So again, following my definition, it could be a many-sided figure, so it could be anything. Okay, so that's a polygon. Doesn't matter what it looks like, it's a many-sided figure made up of segments. What you cannot do is something like this. That's not a polygon. It has to be straight segments. Segments are always straight. Those are not. Okay. Once we know it's a polygon, there's a couple different kinds that we'll look at. For the most part, we're going to look at convex polygons, or shapes that would look like this, and you may even know what this is already. It's called a pentagon, but it kind of extends beyond that invisible line there, and it's going to make more sense when I draw this one. This is going to be a concave polygon. So instead of kind of making a roof there, it's going to draw itself inside here. So instead of being outside that extended invisible line, it's going inside. So that would be a concave polygon. Okay. A regular polygon, think about what the word regular is, you know, he's regular size, he's normal size, whatever. Regular polygon would mean a polygon with all sides being congruent. Okay, so every single side is the same. We have different polygons. Depending on the number of sides, we call it different things. So, you guys already know what a three-sided figure is. That would be a triangle. A four-sided figure, I know you're probably thinking rectangle, square. It could be a number of different things. Rectangle, square, rhombus, parallelogram. So, that would just fall under this category of quadrilateral. Okay, that's going to include all of them. Quad coming from, or four coming from quad. 5 would be a pentagon. 1 you probably already knew. 6 is a hexagon. 7, you're going to see a couple different names. You might see heptagon. You might also see septagon. You're probably going to see this one more often though, heptagon, for 7-sided figure. 8, that would be your stop sign. You have an octagon. 9 is called a nonagon. 10 would be a decagon. That's why they call them decathlons. It's 10, so a decagon. And 12 would be a dodecagon. You don't see 11 too often, but what you would call that is an 11gon or 13gon, 14gon. They probably do have names, but when we get up that high, we just call it an n-gon, or whatever number of sides it is. We would call it like a 76gon. That's how it would work. Okay, so those are all your different polygons you'll see. We'll mainly be dealing with 7 and below, 6 and below, but we will see octagon, especially next semester. So just be prepared for that. To look at the number of degrees in a triangle or in a polygon, we know how many degrees are in each triangle that we've worked with before. You guys know over and over and over again we've said that there's 180 degrees in each triangle. So if we look at this, we have a 4-sided figure, 5-sided figure, 6-sided figure. So a quadrilateral, pentagon, and a hexagon. If we can break this up into triangles, we should know how many degrees are in it. So if we were to break up this into as many triangles as we can, right now we see, okay, 1, 2. There's 2 triangles there. If we break up now this one into, let's see if I can do this. 1, 2. You can only use the original outside segments. So far we have 2 there, 3 here, and then here you're going to have 1, 2, 3, and 4. Okay, so now you have 4 triangles. All you need to do is say, okay, the sum of my interior, and that's what we'll call it, the sum of my interior angles are going to be based on how many triangles there are. So if there are 3 sides, we know that there's only 1 triangle, because that is a triangle. It's 180 degrees. Now if we have 4 sides like we did in that first shape we cut up, that creates 2 triangles, which would mean we have 360 degrees. If we look at the next one, we have 5 sides, that makes 3 triangles. That's going to create 540 degrees. 6, that creates 4 triangles. So you can see it's going up by 180 each time. That's going to be 720 degrees. So in other words, what we're really doing is taking the number of sides, n, minus 2, so we'll go from 6 to 4, minus 2, 5 to 3, minus 2. So it's the number of triangles comes from the number of sides, and you're going to multiply by 180. So it's going to be n minus 2 times 180. Okay, so you're going to take the number of sides, subtract by 2 to figure out how many triangles you would create, and multiply by 180. Okay, and that will work every time. A couple more formulas that we're going to need to know, and these will come up over and over again. I'll decide if I'm going to give you these on the test, but as of right now, I want you to memorize them so you can be quick with it, but we'll talk about if I want to have you guys memorize them for the test or not. We're going to go through a couple problems just to get the kind of method that I want you guys to use as going through these. We have the sum of the interior angles, okay, which is the one we just did. So that comes from straight from there, 180 times n minus 2. It's the same idea. The sum of the exterior, simple. The sum of the exterior angles is always going to add up to 360. The interior plus the exterior angle always equal 180. And the number of sides is always going to be calculated by taking 360 minus the measure of the exterior angle. So there's a lot going on there. Big S just means sum. E means angle. Okay? And then interior, exterior is the little I, little e. Okay, so make sure you know which is which and how you use them. Because even if you know the formulas, you still have to be able to use them. So we're going to look at some examples here and make sure we know how to do these. So first, find the sum of the interior angles of a regular nonagon. Okay, so a couple pieces of information here. First of all, sum of the interior angles. Look at your formula, find which one that is. Sum of interior is this. SI equals 180 times n minus 2. We also know that it's a nonagon, 9. So we're always going to start with the formula we want to use. That tells us the sum of the interior. So all we're going to do now is say, okay, this is easy enough. 180 times 9 minus 2, which is going to be equal to 180 times 7, or that comes out to be 180 times 7. We get 1,260 degrees. So that would be the sum of the interior. So you want to identify the keywords, pick out a formula, sometimes maybe 2, and then work your way back. Okay, let's look at the next one. Find the sum of the exterior angles of a 15-gon. This is about as easy of a problem as you will see in geometry. Find the sum of the exterior, okay, that's the formula we're going to use, of a 15-gon. Okay, so that's another important piece. We already know it's 15-sided, so we look up to see sum of the exterior angles is as easy as it gets. Nothing to plug in, simply going to be 360 degrees. That will always be your sum of your exterior. Okay? Because if you think about it, let's say we have a pentagon. No, I'm going to draw a hexagon. What that's asking for is all these little angles out here that go off, and they always are going to add up to 360 degrees. So all these little acute angles, so this angle, this angle. All these little angles in here are always going to add back up to 360, no matter what kind of shape it is, because the bigger, the more the amount of sides, the smaller those angles are going to get. So always adds back up to 360. Find an interior angle. Okay, so find the interior angle of a regular dodecagon. So I just want to know what one angle is. Okay, so let's look and see if we find that anywhere. Find an interior angle of a dodecagon. If you look back up, a dodecagon is 12 sides. Well, I don't see anything where I just get one interior angle, but I do see the sum of the interiors. If I know the sum of the interior, I can figure out what just one angle is. Because if I have 12 sides, I also have 12 angles. So I'm going to go ahead and use the sum of the interior is 180 times n minus 2, minus 2. And I'm going to go ahead and plug in my 12 here. So I'm going to get 180 times 10, or 1800 degrees for the sum of the interior. Now remember, I don't want the sum of the interior. I just want to know what one interior angle is. So what I'm going to do is cut that, or divide it by 12, because I just want one angle. If there's 12 sides, there's 12 angles. That's going to give me, so my interior angle, that's how you would label it, is going to be 150 degrees. Okay? We'll do one more here, and then I'm going to spend some time tomorrow in class doing a couple of these. Maybe I'll have you guys work ahead too. Name the regular polygon that has a SI, so let's see if we have that. SI is right up at the top, of 2,880 degrees. So again, highlighting your important information, we want to know, name the polygon that has a SI of 2,880. Okay, so we're going to use that formula. SI equals 180 times n minus 2. Always using the formula that you have words for. So what we have is SI equals 180 times n minus 2, which again we don't know the sides. So what we want to think about is, we know SI, the sum of the interior, is 2,880 equals 180 times the quantity of n minus 2. If we can get n, we know we can name it. So we get n by itself, we're going to divide by 180, and that comes out to be, let's see here, 16 equals n minus 2, add 2, so we're going to have n equals 18, which, naming it, we would call it an 18 gon. There are, let's see, 11 problems left. Okay, so we have 5, 6, 7, 8, 9, 10, 11. I'd like you guys to try 3 of them. So if we have 6 problems left, I'd like you guys, or 7 problems left, I'd like you guys to try 3 of them. Pick which ones you want to do. You can pick any 3. You can do them all if you want. I want to see 3 done for tomorrow, and then we're going to go through together, figure out which ones you guys know well. Maybe other people know certain ones well, other people don't. But don't just do 5, 6, 7. So pick any 3 random ones. You can do 5, 8, 11. Pick out 3. Make sure those are done for tomorrow, and then we will go over them in class. See ya.